You can freely download this practical notebook from my website. From its home page, go to middle left and click Books and Notes. A new web page will open. Then download third book in PDF format. Experiment 8 of part 2 in practical notebook. Left side page of same experiment.
Welcome students. We are starting a new practical in electricity today, and the name of this experiment is to determine the EMF of a cell using a potentiometer. Apparatus for this experiment: potentiometer, battery, 2 cells, galvanometer, voltmeter, rheostat, jockey, 2-way key and a plug key. This is rheostat, battery. These are the 2 primary cells which we are using in the experiment. This is galvanometer. This is jockey. This is 2-way plug key. This is 1-way plug key. In the circuit diagram, you can see that these 4 lines, they represent potentiometer. This one is the rheostat, 1-way plug key, battery, and these are the 2 cells, primary cells which we are using. This portion represents 2-way plug key. This is galvanometer, and this galvanometer, it is connected with the jockey. Coming back to the apparatus, now we will connect all these components in our circuit. Here you can see that with this potentiometer, with the terminal B, we have connected through this wire, we have connected rheostat, and the terminal C of the rheostat, it is connected through the wire with this plug key. Other end of the plug key is connected with the battery, and you can see that this is the negative terminal of the battery. Now the positive terminal of the battery is connected with end A. Now then here, this whole circuit, it is connected, all these 4 components, this rheostat, plug key, battery and this potentiometer, they are connected in series. Now we have to connect the 2 primary cells. Positive terminals of these 2 primary cells, they have to be connected with this terminal A. Then the negative terminals of the cells, they are connected with these extreme ends of the 2-way plug key. The center terminal of the 2-way plug key, it is connected with the black terminal of the galvanometer. Now the positive terminal of the galvanometer, it is connected with this jockey. Students, for our performance, we have to check whether these connections which we have made, they are correct or wrong. Now for this thing, first of all, insert this plug key so that steady current flows through the circuit, through this potentiometer. Then after that, insert this key so as to bring this cell, which is E1, in the circuit. Here you can see that this key, which is key K1, it is on and K2 is off. This shows that this cell, it is out of the circuit, and this cell, which is E1, it is included in the circuit. Now place your jockey at terminal B. The deflection of the needle on the galvanometer, it should be towards the extreme end. But here in this case, we can see that it is not at the extreme end. So the reason might be that any connection could be loose, or friction, or any resistance between the components. Then after that, place your jockey towards the terminal A, and here on the galvanometer we can see that deflection of the needle is towards the opposite extreme end. After that, we will switch over the key to K2. This will ensure that now our cell E2 is in the circuit and E1 is out of the circuit, because here you can see that this key, it is off. Now again we have to do the similar procedure, that we have to place the jockey at terminal B. The deflection is at one side. Then place the jockey at terminal A. The deflection should be at the opposite direction, in the opposite direction. Now, in assuring this, that the direction of the deflection of the needle is in the opposite direction at both these terminals, this assures us that our connections, they are right. Now for the performance, that we have to compare EMF of a known cell with the EMF of the unknown cell. Now for this thing, from these two cells, this one, it is E1, this one is E2. So we will find out EMF of cell E1 with the help of voltmeter by connecting its positive terminal of the cell with the positive terminal of the voltmeter and negative terminal of the cell with the negative terminal of the voltmeter. Now this EMF which we have seen, which we have noted with the help of this voltmeter, that will be the known EMF, and this is the cell whose EMF we have to find by comparing it with the EMF of the cell E1. Now for this purpose, what we will do, that we will insert this plug key, and by inserting the plug key, this ensures that the steady current from the battery flows through this potentiometer. Now insert this plug K1. This shows that our cell E1, it is included in the circuit, and cell E2, it is out of the cell. Now after that, with the help of this jockey, we have to find the balancing point or null point. Balancing point is the point where galvanometer shows zero deflection, or in other words we can say that galvanometer shows zero reading. This means that at that point where galvanometer is showing zero reading, no current is passing or flowing. Now for this thing, in the potentiometer you can see that there are these 4 wires, and it is obviously not possible that we have to drag this jockey on these 4 wires to find the null point. So what we will do is that I'll place jockey on this first wire. Here I can see that the needle, it is still towards the negative side. Then I'll place jockey on the second wire, and here I can see that the needle has gone towards the positive side. This shows that the switch over from negative to positive terminal has taken place between these 2 wires. Now I have to find out the null point in between these 2 wires. Now for that thing, I will not slide this jockey on these wires. Simply I'll just put the jockey at different points on the wire, and we can see that this needle, it is moving towards the 0. At this point I can see that this needle, it is almost at 0. So here for this small short distance, I can just drag this jockey on this wire slightly to find out the 0 deflection. Now here you can see that at this point our galvanometer is showing a 0 reading. So after that, the next step is that we have to note down this reading. So that I'll do with the help of the scale. So the reading which is shown over here, that is 96.5. On the scale the reading is 96.5. But as I told you earlier that this reading, it will not be 96.5. The reason for this is that all these 4 wires, their length of each wire, the length of each wire is 100 centimeter, and our null point is on the second wire. Null point is on the second wire. So for this, there is a little technique with which you can note down the reading. This first wire, it is of 100 centimeter. Second wire is of 100 centimeter. Now 100 and 100, 200, and here you can see that this third wire, which is again of 100 centimeter, but on the third wire the null point is at 96.5 centimeters. Now the easy way of noting down this length is that you know that each length of this wire, it is 100 centimeter. So this is 100 centimeter, this is 100 centimeter, so it is 200 centimeters, and our null point lies on the third wire at 96.5. So subtract this 96.5 from 100 and we get 3.5. So this 3.5 will be added in this 200. So the total or the final reading will be 203.5 centimeters. And this will be our first length, which is L1. So we will note down this reading L1 in our table. So this is 203.5, which is the balancing length for cell E1, and it is L1. Now we have to find balancing length for cell E2 with the similar procedure. We have to find the balancing length of cell E2, and for that purpose, first of all, disconnect this plug key, then move this key to the other plug key. In this way, what happens that this cell, which is E1, it is out of the circuit, and this cell, which is E2, it is included in the circuit. Now we have to do the same thing. Place this jockey at the fourth wire, and then at the third wire, and again we can see that the balancing point is in between these two wires. So we have to find the balancing point Again with the same procedure, that I will move this jockey step by step on this wire. Now here you can see that the balancing point for cell E2, it lies on this 4th wire. So we have to find out the reading. So that we will find again with the help of the scale. And here you can see that the scale points 97. Now again, the reading is not 97. Here you have to see that 1, 2, 3 and the balancing point lies at the 4th wire. Now the readings which we have observed here, the length of L1 and length of L2, we have written in our table. Now these are the actual values. You can see here that the balancing length for cell E1, L1, that is 284.5 centimeters. Then balancing length for cell E2, which is L2, it is 298.5 centimeters. Now putting these values, all these 3 values in this formula, we have found out that the value of E2, that is EMF of the cell E2, it is 1.33 volts. This is one set of observation. We have to take 2 more observations by slightly changing the position of rheostat for each observation. After that, we have to take mean EMF of the cell E2. Like we will have 3 values here of E2, we will take mean of these 3 values, and that will be the end result, that mean value of cell E2. And here we have seen that it is 1.34 volts. Now in the end, let me tell you one thing, that there are few points which you have to remember. While when you have to take L1, that is the balancing length for the cell E1, the points which we have to remember is that your key K, which is this plug key, it should be on. Then K1, this is K1, this K1 it should be on. When this K1 is on, it means that this cell E1 is included in our circuit, and K2 should be off. This is the condition for finding balancing length L1. Then for the second line, when we have to find L2, this K, which is the plug key, this should be on. K1, it should be off. This means that this, we have to open this key. By opening it, it means that this cell E1, it is out of the circuit, and when we insert the plug key here, or in other words, when we turn on K2, we are including cell E2 in the circuit. So this is the condition for finding balancing length L2. These are the 2 points which we have to remember in order to find L1 and L2. Now dear students, I'll tell you the method how to peel the wire. with the help of which we will peel off this wire. Here you can see that the wire is not peeled. So this slot, this one is the last one, it is a wrong one. Here you can see it is loose. Second one is also loose. So we will place in the third slot and we will just put a normal pressure and we will press it and by pressing it, it will just peel off the wire. Now we need some more, so I'll so this is the way how to peel our wires. Now after that, for checking the connections, that the connections they should be tight, I'll tell you the right way how we can make the connections. To make the connection with this type of wire, which here you can see that it is not properly peeled. So if you make connections with this type of wire, your connections will not be correct. Like, see, it will not go in this screw, and afterwards what will happen, that it can slide, it can come out. So this is the wrong way. So you have to peel your wire more with the help of that, peel your wire more with the help of this cutter. Then fold this wire like this and tighten your screw. And this way you can see that this wire, it is tightly screwed up and it will not come out easily.
You can take this objective physics practicals from Ilmi Book Depot, Urdu Bazaar, Lahore, or you can download directly from my website. Your readings may be different from these readings. Check these readings as a reference. Thank you.